Well, good morning, good afternoon, evening, and nighttime to everyone, wherever you may be, somewhere in our world. Thanks so much for joining us here live today for the one and only Serverless Office Hours, streaming on the AWS Twitch channel, YouTube Serverless Land, and LinkedIn Live. Thanks so much for joining us. I'm Julian Wood. I'm a developer advocate here in the Serverless team, and today I'm super happy to have returning guest extraordinaire, James Eastham, who's a solutions architect with our professional services division. So James is the people who go out into customers and build awesome applications. James, welcome back to Serverless Office Hours. For people who don't know you, just remind people who the awesome James is.
The awesome James, gosh, that's one of the nicer intros I think I've ever had. Yeah, maybe. So yeah, hello everyone, back again. So I'm James, as Julian said. I work in the AWS professional services part of AWS. I always like to say by day, I'm a professional services consultant working with our customers building things, and by night, I love all things serverless.net. So I'm a .NET developer from a .NET background. I've done everything from frontline support to SQL Server, DBA, to deploying Windows .NET applications to Windows servers and IIS and all of that fun stuff. I think that's why I like serverless so much, Julian, because I've spent so many years as a DBA and working with Windows servers and having Windows services fail unexpectedly. So I think that's part of the reason why I love serverless so much.
That's exactly my my background. I mean, you're from more of a development background, but I'm from the operations and infrastructure background. Also, working in big enterprises, looking after fleets of hundreds, thousands of Windows servers. Not that the Windows servers necessarily are a bad thing, but just stuff goes wrong. And when servers came along, and it was just like, we don't have to do any of that, and it scales, and you only pay for what you use. Awesome. Anyway,
I'm still trying to find. I'm still trying to find every time I speak at user groups. I'm still trying to find a developer who will stick their hand up to the question, "Who here loves operational overhead?" And I'm still yet to find somebody to put their hand up. And I'm like, please, somebody put your hand up.
One day, yes.
One day, yeah.
Well, James is going to be talking all things .NET, but before we get back to James, just looking quickly over the past week of serverless on AWS. Last week was all about APIs. So Daniel Woods was talking about well-architected API gateway APIs, whole bunch of tips and tricks and information just about building your APIs with all the goodness that's available. And that is on our Serverless Land YouTube channel, youtube.com/serverlessland, along with all other previous Serverless Office Hours episodes. In terms of what's new this week, we have Lambda's come out for improved responsiveness for queue and stream event-based sources. So if you're using things like Kafka and RabbitMQ and managed MQ, and this can be Amazon MSK or self-managed Kafka. Definitely another one in there, but it slipped out of my brain. But basically, it used to take up to 15 minutes to, if you did a config change, and I know this because I've done a whole bunch of work with Kafka over the past year, and you just want playing around and like, I'm going to do a config change, and that's going to take a while. Well, now it's 90 seconds. So that is super awesome, just to be able to do things far more effectively. Also, step functions add some support for open workflow metrics. So workflows that are open, that are currently in flight. So that's super useful for managing your scale and your operations. And an interesting one from EventBridge about API destinations now supports some sort of content type header customization. And this is actually when you're working with things like cloud events, where you can sort of munge and change the headers as it's going through EventBridge. And that's just another useful thing to be able to use with other applications. In terms of compute blog posts, we are going to cover a bit of this one today, or certainly the top two. Design approaches for building serverless microservices from Luca and Matt. Yeah, really great blog post. Just talking about some of the things to think about, whether you want massive Lambda functions or smaller Lambda functions or somewhere in between. Super useful. So I encourage you to take a look. And then obviously the second one down, .NET 8, now available in Lambda. And Bo and Paris have put together some really good blog posts going through all of that, which James is going to be expanding in cool detail today. It's coming up to AWS Summit season. So, these are in-person events around the world. This is just a list at the moment. There are going to be more added. I'm actually going to be speaking at the London event. I know with James as well. So come and say hi on the 24th of April, but register beforehand. It'll be super great to see you. Yeah, Summits are great events, huge, get lots of AWS information and free. So well worth your time. Another event that we are running, our team is running on May the 14th in London, is also called EDA Day, Event-Driven Architectures Day, put together by the GoTo team. So GoTo is a set of conferences around the world, super well managed. And we did a GoTo EDA Day in London a year and a half ago, which was fabulous, fantastic. And so we're coming back for another run, lots of great content. So yeah, sign up at the URL on the screen, and would also love to see you there. So that was the past week, including the .NET 8 release for Lambda. James, tell us about .NET 8, because I know there was a .NET 6 on Lambda. There was sort of ish a .NET 7. So yeah, tell us sort of the history of .NET on Lambda, if you can.
Yeah, so when obviously .NET historically was a Windows-only language with .NET Framework, and probably, I don't know how many years ago now, 6 or 7 years ago, Microsoft did this big push to make .NET cross-platform. So you could run .NET on Linux, .NET on Windows. And as part of that, they committed to a yearly release cycle. So they release a new version of .NET every single year. All the even versions are LTS releases. All the odd numbers are short-term support releases. So short-term support, I think, is 1 year. LTS is 3 years. Obviously, aligning with the Lambda policy of only supporting LTS releases, that's why we got .NET 6 as a managed runtime. We didn't get .NET 7, albeit you could still run .NET 7 on Lambda using custom runtimes. And then, of course, we get .NET 8, which went GA in November last year.
So yeah, .NET 8 GA in November last year, and it is only, well, end of February, and yeah, .NET 8 on Lambda is out. So that's also really cool how Lambda has really sped up the releases past GA announcements for these runtimes, which is also cool.
Yeah, it seems like that's across the board as well. There seems to be a lot of runtimes now. They seem to be coming at like a feral cadence now. Was it Java 20?
3.1, yeah,
not so long ago.
Python 3.12,
3.12. I was going to say 3.9 then. That shows how much I know about Python there.
But yeah, but that's also, that is actually a Lambda goal, is to get the runtimes out quicker. And there's a whole bunch of internal work done last year to speed up the process and to just break things apart. We were, parts of Lambda also run as a bit of a monolithic application behind the scenes, and they were split up to allow us to be able to do these kind of things. And part of it's just the Lambda platform to be able to do these, but part of it's also, there are some quirks and tips and tricks with these various runtimes which need to work super well on Lambda. Wouldn't be good if a new version came out and there was a performance degradation or some kind of incompatibility with a library that's used in the operating system. So yeah, plenty of work that goes in. I was actually in Dublin last week talking to some of the language runtimes teams. A whole bunch of people who working hard to get the runtimes out as quickly and performant as possible.
And that was one of the really interesting things about the .NET 8 managed runtime. So actually, as part of us building the managed runtime, we actually found and fixed an upstream issue in the .NET runtime itself, in terms of how SSL certificates are loaded. So the .NET runtime was actually loading them twice, which had a performance degradation. And as you said, we then pushed back the runtime release slightly to actually go and fix that issue. So that's us contributing back upstream into .NET, what will become .NET 9 later this year. So super cool.
Yeah, that's fantastic. I love that too. Well, didn't love it when internally it was like, oh no, we've got a performance degradation. But yeah, to be able to find it and push code back up to the source language runtime is cool.
Yeah, definitely. So in terms of .NET 8 itself, there's not an awful lot of there's a whole bunch of performance features that just make .NET faster. In terms of game-breaking stuff for Lambda specifically, there's not a whole lot of new features in the .NET runtime itself. However, there's still lots of interesting stuff we can talk about today. The biggest one that we'll get into is some improvements around the native compilation for .NET. So one of the cool things that Microsoft released in .NET 7 was full GA support for native compilation. Native compilation being you actually take your .NET application, compile it down to a native binary in a similar style to the way Rust or Go work. And that dramatically reduces cold start times. Startup times, which would then have a knock-on effect of improving cold start times.
So is the whole sort of native compilation thing just a performance thing, or are there other factors that people would think of?
There are some pretty big trade-offs which you can get into as you take on native AOT. Like, it's not go on native AOT all of your .NET Lambda functions across the board, because there are some things you need to consider, and we can get into some of them. But for net new workloads, or then workloads on Lambda where you just need really, really, really high performance, then it's a really interesting place.
So that would be sort of more, I suppose, things behind an API, something that's synchronous, where it's actually user-facing. If you're doing a lot of asynchronous kind of things, and unless it's as low latency as possible, I don't know if you're doing sort of some stream processing or things like that, where you want pretty fast pipelines. But if you're just running like a scheduled task that happens at 1 a.m. and whether your Lambda function takes a few seconds to get going,
I mean, especially with .NET on Lambda now, we're pretty consistently, if you're using the full serverless stack, the API gateway, Lambda, Dynamo, typical example, you can pretty easily get 600, 700, 800 millisecond code start time, which is in a lot of cases okay for the vast majority of synchronous workloads. And then when you couple that with the fact that a steady state API, the number of code starts is typically relatively low as a percentage. Even for some synchronous workloads, you might not need native AOT, but you're absolutely right. For them really specific cases where you just want it to be as fast as physically possible, then native AOT is an excellent option.
Okay, excellent. And yeah, just remember, we are live here, so send us your questions and comments via whatever platform you are joining us from. Even say hi. Thanks so much, Andy Mahalik. Thanks for joining us as well. And Daniel from Brazil, hello for joining us as well. And actually, seeing we are talking cold starts, Chuck says, still waiting for initialization time optimization for Lambda. It's disappointing when initialization takes longer than the running code. I wonder how long will it take for .NET 8? So Chuck, I just wonder if you wouldn't mind just clarifying the ask. Are you looking for additional optimization that the Lambda platform should do? Because obviously, if you're running code in .NET 8 or in any language and you're setting up a whole bunch of stuff, there is some work that you can do to optimize your code. What kind of things would you like Lambda to do? Yeah, let us know.
Cool. So while we wait for Chuck to get back to us, where I thought I would start is actually the upgrade path from .NET 6 to .NET 8.
Yeah.
Because Microsoft do a fantastic job with .NET of making it backwards compatible. So I've got an example repo on GitHub, which I think if I send to you, you could share in the Twitch channel.
Yeah, certainly.
That is actually inspired by some work that one of the serverless heroes did. So Ran Eisenberg has a really great repo, the Python.NET Handler Cookbook, which is kind of an opinionated way of doing Python with Lambda. So I tried to replicate a similar thing for .NET, and I've actually got that bumped up to .NET 8 now. And I actually just wanted to show everybody the diff in terms of the commit where I bumped things up to .NET 8 to actually.
Okay. Should I share your screen? I don't want to
you could share my screen.
I just want to put it on if it's cat videos or something.
Well, we could all watch cat videos for the next 45 minutes, I suppose. That could be fun. So this is the actual diff from GitHub in terms of everything that I had to change to bump this .NET 6 Lambda function to .NET 8. And the big one is across the board, I actually had to update the target framework. This is in .NET itself in your project file from Net 6.0 to Net 8.0. And almost entirely across the board, that same change applied. So all of the project files across this entire solution, this happened to be a .NET 7 function that was bumped up to .NET 8. It was actually as simple as doing a Control F across my entire
search and replace,
find and replace Net 6.0 with Net 8.0. So that was all I did, and that just bumped all of the actual .NET project files up to .NET 8. So that was step one. And then step two, so I'm actually using the CDK here for this stack. And step two was simply to change the runtime from .NET 6 to .NET 8. And that was basically it. I had to update my version of the CDK locally. I had to update my CDK constructs, obviously to get the new versions of things. And that was as simple as it was to actually bump the Lambda function of .NET 6 to .NET 8. Some of this is native AOT, some of this is not native AOT. It was really that simple just to bump things up, and it was off and running .NET 8 on Lambda. It was actually really cool.
Okay, so I suppose because .NET has, more of a, not necessarily a compilation process. I mean, it does for the AOT kind of stuff, but there is a build process involved that it is just going to grab the latest files from a different, the new language runtime and off you go.
Yeah, exactly. And the way the .NET SDKs work, if you've got the .NET 8 SDK installed, you could still compile a .NET 6 function. So they do some really awesome work behind the scenes in .NET with making all these things really easy to move around and jump between different versions of .NET, and things just work almost exactly as you would expect. So that was really cool, just to bump things up, get things going, and we were off and running .NET 8 on Lambda, which was really cool. Where I thought I'd go next is to this idea of running web APIs on Lambda, the Lambda lith, as it's becoming more and more known now, because that's one of the really interesting patterns one of the really interesting places that .NET has made improvements is with native AOT, and particularly with ASP.NET. So ASP.NET is the .NET framework for running web applications, similar to Flask or Express or Spring Boot. ASP NET is the .NET version of that. And with .NET 8, Microsoft announced GA support for native AOT for ASP NET. So in .NET 7, you couldn't do ASP NET with native AOT, and now you can in .NET 8. And this is really cool because this you kind of reference Luca's blog post, and it might be interesting to talk about this for a few minutes with people listening about.
No, certainly will do. We did also have a question about from Silas. Does it apply to classic ASP.NET or it's about ASP.NET Core?
ASP.NET Core.
Okay, and that's because it's Linux, and so the ASP.NET, anything that, well, not everything, but in the .NET Core world, that's the cross-platform one.
Yes, exactly.
Cool, excellent. So yeah, as James says, I'm just going to put there was a blog post that I mentioned earlier about comparing design approaches for building serverless microservices from Luca and Matt. So that's the link on the screen and also in the chat. So yeah, well worth having a look at, specifically if you're building web applications.
Yeah, because what you can now do, if I jump over to my ID now, that has changed. Excellent. So when, I guess if we go back a few steps before we talk about native AOT. So with .NET and Lambda, AWS, we have produced a library that you can add to your ASP NET applications that actually allows you to drop an existing ASP NET application straight into Lambda. So that library is that one there, which is Amazon Lambda ASP NET Core Server or ASP NET Core Server hosting. And this library allows you to take an existing ASP NET application, run that in Lambda, and that ASP NET application will then just run in Lambda. If I look at the startup code for my actual ASP NET application, it is as simple as that. So if you're building with the minimal API syntax in ASP NET, which most people probably will be now, this is all you need to do to add ASP NET and run ASP NET inside Lambda. And what's really cool about this, Julian, is that this library is context aware. So I can actually take this ASP NET application as it is. I could run it locally and it will just start up locally. I could run it in a container and it would run in a container. And the second I drop it into Lambda, it then starts up the ASP NET application differently. And it starts it up ready to take that JSON payload that comes into Lambda, translate that into something that ASP NET understands, send it through the ASP NET pipeline, and then back out the other end. So it's a really cool way of doing it because you can just take this exact same application now, drop that into Lambda, and it will just run in Lambda.
Wow, fantastic. So that's sort of taking the idea, I know with other languages, there's the Lambda web adapter, which does that translation, JSON to HTTP, and then back out HTTP to JSON. And there, this is just built into .NET for Lambda.
Yeah, exactly. Yeah, I think the Java world has a similar thing as well. I hope I've not just offended all the .NET developers listening by saying that naughty word, but yeah, the serverless Java container does a similar kind of thing in the Java world as well. So this makes it really easy to obviously take and, as I said, to drop existing ASP NET applications straight into Lambda. If we wanted to native AOT size this now to make up a new word, there's a few steps that you have to go through to do that. And obviously the benefit of doing that is that you will then get a much faster startup time for your application, which will then obviously directly impact the cold start time of your Lambda function.
So this was also, just to roll back quickly about Luca and Matt's blog post, which I was referring over here, because also looking at the screen over here, you can see this single application has got an add route, a subtract route, a multiply route, a divide route. There's a whole bunch more stuff going on in a Lambda function. And previously, I think for really good reasons, people were, well, let's have separate Lambda functions for different functionality, maybe for different routes around an API. And I think the original reason was, well, you maybe have different performance requirements, you maybe have different libraries that you need to load, you maybe have different things, and a function for a single purpose can be really useful because you can use the power of Lambda with its nature of a isolated runtime environment, safety, security, performance, all that built in. And that is great. But the problem is when you are then running a busy website, and you've got a lot of different routes, you'll end up creating a lot of different Lambda functions. And that becomes, one thing's a performance, slight potential performance overhead, because maybe your divide route doesn't get used very often. So but it needs to be high performance. So when you do, head to the divide route in your API, well, that's going to, run another Lambda function, which maybe is going to then do a cold start. So you're going to more of your functions are going to have cold starts. And then also from an operational perspective, you need to do some upgrades, you need to do some patching, you need to understand concurrency, you need to do limits, metrics, monitoring, logging, all these kind of things in a whole bunch of different places, a whole bunch of different Lambda functions. So that's on one side. On the other side, you can put every single thing into a single Lambda function, and you can have a massive big Lambda function, which could have all your API routes. Again, works really easily, but you may then have a lot of code that's running in your Lambda function that isn't being used. You may have to have really permissive security boundaries because maybe you're connecting to multiple databases or multiple APIs. And so, that becomes a bit of a sort of big box to look after, which can also be complex. And for example, if say your multiply route gets super busy, you don't have a sort of way to independently scale that or handle any of that kind of code. So the sort of the way people talk about it, and I like to use the sort of pragmatic Lambda function, is the best tool for the job, or the best way you're going to do it. And maybe you're not going to do a single route per Lambda function. Maybe you're not going to have all your routes in a single Lambda function, but sort of some combination. And one example that Matt and Luca did in their blog post was, well, maybe your read parts of your API routes can be in one function and your write parts can be in another one, because maybe behind the scenes you're able to optimize your database separately. So, for example, you could read from a read replica while you would write to a master, or the database that handles writes. And so you've got secure functionality, you've got that slight isolation which can help you, but you haven't got this operational overhead of just having to maintain and manage like so many different Lambda functions. So as with all best practices, it always depends. Some of the things that I've even said beforehand of even, talking about a Lambda lith, that also puts people off, because people think, oh, I've had this huge big .NET application running on a multiple EC2 instances. It was, 7 trillion lines of code, maybe not as much, but call it 10,000 lines of code. And I've done the really good thing, and I split it into some microservices, and maybe I've got, 8 to 10 Lambda functions, and now you're telling me that's not good enough. It's still a lith. A lith is a bad thing. I was trying to get away from the lith. Not necessarily. So, be pragmatic. What's going to work with you, your coding practices, how you are sharing code between developers, your team organization, all those kind of things. Bigger Lambda functions don't necessarily mean it's worse. Just it's all about trade-offs. So yeah, a bit of a long-winded rant, but
I really like your pragmatic Lambda function, actually. That's quite a nice way of putting it. I was trying to think of a better succinct way of describing Lambda lith, but yeah, pragmatic Lambda functions. I think I like that, Julian. Steal that. So one other thing I will add, actually, just to what you were saying, one of the things at least when I'm talking to .NET developers, one thing they also really like about this approach of doing things this way is that you can still then start up your application locally. You can add breakpoints, you can debug it locally. You've got that same experience that you might be familiar with, just to run your application locally, which is something that's quite helpful as well. So with the benchmarks we've ran for ASP NET and Lambda, this kind of setup, this running ASP NET on Lambda approach, is typically between 1.5-2 seconds in terms of startup performance. That's typically what we see. When we native AOT assigns this, which we'll go through and do shortly, that can get as low as 600-700 milliseconds. So we're in that kind of sub-second sweet spot, which is what at least I've seen from talking to people using Lambda. It tends to be the kind of place where it becomes okay for a cold start to take, as long as it's less than a second. So the first thing we're going to do with this Lambda function is we're actually going to turn on native AOT. So to tell the .NET compiler that you want to do native compilation, you need to add this publish AOT flag and set that to true. So this will now tell that when I compile this application, the .NET compiler is going to look at that and say, okay, James wants to do native compilation, and I'm going to do the second step to natively compile that. The second thing you need to do if you don't already have it set up, so with when you compile .NET applications, you can set the output type. That's the wrong property, James. Because this is just going to generate a single binary now, a single file, then you need the output type of your application to be an executable. So you need to have this executable that then, in this case, Lambda can just execute, and then that will do everything else. So when we generate this executable file that's going to be natively compiled, that's going to run, and it's going to hit this is going to be the entry point of the application, at which point it's going to set up the Lambda hosting when it's running inside Lambda. So they're the two things you need to do in your project file. You need to turn on native AOT, native compilation, and you need to set the output type of your application to be an executable. Step one. Step two are some actual code changes that you'll need to make in your application. So this create builder bit right up at the top here, this first line, it's probably a line of code if you're building .NET applications that you've never even noticed exists before, because it's kind of just there and it kind of just works. This create builder method does a lot of, sets up a lot of boilerplate behind the scenes. It sets up a lot of the glue to kind of make ASP NET work. And although Microsoft have announced support for native compilation for ASP NET, it's not quite full support. So you can't do all the things you're used to doing in ASP NET in natively compiled ASP NET. And there's a really good documentation on the .NET documentation site for covering this. So what you'll need to do is you'll need to change that create builder to this create slim builder method. And all this is a slightly slimmed down version of the ASP NET framework, if you will, that's going to be natively that supports native compilation. So now you can guarantee that this ASP NET application, or the startup, or the glue behind the scenes, is actually going to support a native AOT, albeit not fully featured native AOT.
Can you use create slim builder if you're not doing native AOT?
Yeah, absolutely. Yep, and that will still affect, that will make your non-AOT application start up faster as well. You can also do, I've not actually used this yet properly, but there is actually a create empty builder, which does literally nothing, and then you've got to manually add all the really specific bits of ASP NET that you want to include. I've not tried that out yet, but yeah, that would still be a good thing to do if you're not using native AOT. Then we start to get into some of the trade-offs of using native AOT. The biggest trade-off that you make, in my opinion at least, when you're using ASP native AOT, is around JSON, working with JSON. So the two primary ways of serializing and deserializing JSON in .NET, they really heavily use reflection inside .NET. And because of the way native AOT works and the trimming works, you actually lose the ability to do a lot of the reflection-based features in .NET. And what that means is that if you natively compile a .NET application, you try and serialize or deserialize an object inside that application, it's probably going to fail, because either the trimmer will have trimmed away a whole bunch of application code. So you need to actually manually is the wrong word. You need to do some additional stuff to be able to work with JSON inside natively compiled .NET applications. So what you need to add is a new bit of code to your project. You can call this whatever you want. I normally go for something like custom serialization context, something like that. And that code needs to inherit from this JSON serializer context. And you need to make that a partial class. Once you've done that, you then need to add this JSON, and I'll explain all this in just a second. Let me just type it all out. So you need to add this JSON serializable attribute, and then you need to specify all the different types that you want to be available for JSON serialization and deserialization. And what this is using a feature of .NET called source-generated serialization. And what that means is that all the code required to do serialization and deserialization of JSON is generated at compile time. It uses a feature of .NET called source generators, which allows you to generate code at compile time. So at the point I build this application or publish this application, it's going to generate a whole load of code in the back end as part of the compilation process to actually be able to serialize and deserialize these two classes. So this is something that you would need to do. Let's say you had, a product object in your code, and you also had, I don't know, a orders class. You would need to go through and add all of the different types that you want to be available for JSON serialization, and that will ensure that things can be serialized and deserialized. One thing to always remember is to actually include the types for the actual Lambda event source. So you see, I've got the API gateway request and response objects. You'll need to make sure you include them so that the Lambda runtime can actually serialize and deserialize your the input events. This, again, much like the create slim builder, Julian, this will also have an impact performance-wise if you're not using Native AOT, because this is now using code that's being generated at compile time to do JSON serialization and deserialization. So this will be faster, even if you're not doing Native AOT. You can still use source-generated serializers, which is kind of cool. Once you've got that source-generated serializer configured, you also need to tell the Lambda runtime to actually use that source-generated serializer. And you can do that by adding an additional property to that add AWS Lambda hosting method that we use to be able to run ASP NET on Lambda. And then you can add this additional options section to actually configure need a semicolon there, to actually configure a source-generated Lambda JSON serializer and passing in that custom serialization context that I've just created. So this is now telling the Lambda runtime to use a source-generated serializer and use this custom serialization context to do that. One thing that's really cool, you see I've got this yellow squiggly underneath all this code, and this yellow squiggly is actually telling me that if you're using Native AOT, it's detected that I've set publish AOT in my project file, and it's saying just make sure that if you're using Native AOT, that you pass in the overload for a source-generated Lambda JSON serializer. So it's actually smart enough to know that I'm using Native AOT, and it's saying if you're doing Native AOT with ASP NET, make sure you add this additional piece of code as well. So it's actually telling you, reminding that you need to do that, which is kind of helpful, really. Then the one final code thing you need to change, and here's one I made earlier in true Blue Peter style. You actually need to tell ASP NET itself to use that custom serialization context as well. So this is not something specific to Lambda. This is specific to ASP NET and .NET. But I'm telling ASP NET itself, use this custom serialization context that I've just created. And that is now ready to run on Lambda. This ASP NET application can be natively compiled and it can run inside the context of Lambda, which is kind of cool. So let's actually give that a try now, shall we? Here's the moment of truth, Julian.
So just thinking, if you had, for example, something from secrets manager or parameter store or that kind of thing, you need to then specify those other kind of things that you're adding in your Lambda function so they get compiled as well?
Yeah, exactly. So if you were, let's say you were using Secrets Manager, we'll stick with that example. Obviously, you'd add the Secrets Manager SDK for AWS.
Yeah.
And this is so one of the tricky places that Native AOT is in at the minute is because when you natively compile a .NET application, it really heavily trims all of your application code, and parts of the .NET ecosystem are trim friendly, parts of them aren't. So one of the things we actually released just after reInvent last year is that all of the AWS SDKs are now trim friendly. So you can use any of the AWS SDKs as part of your .NET applications, natively compile them, and they will work. If you're using libraries that aren't trim friendly, let me just show you this other example here. There's a way you can actually tell the compiler to exclude certain libraries from trimming. So here I'm saying, for example, the API gateway events, so the actual objects from API gateway, I'm telling the trimmer actually don't trim them, leave them exactly as they are. The same for the Lambda runtime, the same for that hosting library. I'm just saying, please exclude these from trimming. So you might find that depending on what you're doing, what dependencies you have, what packages you're using, you might actually need to exclude some libraries from trimming. But the AWS SDK is trim friendly, which is really cool.
Yeah.
Did I run a SAM build command? Yes, I did. Good. So the other thing, one of the other trade-offs that you make is that your compilation time will be slower, because after it's actually compiled the code, it will then also do the trimming and it will do the native code generation. So your build times will slow down. It can be quite considerably if you've got a reasonably large application. So that's another thing to be aware of. One of the really cool things that happens behind the scenes when all of this is going on, if I scroll back up through all of this nonsense, and I will explain some of it in a second, one of the challenges with Native AOT is that you need to compile your .NET application on the same processor architecture and operating system that it's going to run on. So in the case of .NET 8, and Lambda. That's Amazon Linux 2023. It's one of the, is it the second or the third runtime that's 2023? Something like that.
Third, I think. Third or fourth. Definitely, I think Python 3.12, Node 21, and Java 21. Or is it Node 20? No, Node 20 and Java 21, I think, or AL 2023.
AL 2023. And I'm sure next to nobody listening is using Amazon Linux 2023 as their build machine. So how do you get around that? Because you need to compile this application on Amazon Linux 2023, but none of you are actually using Amazon Linux 2023, I'm sure. And we've actually built this into the actual .NET tooling. So you'll see after I run my SAM build command up here, this actually, what actually happened, or what SAM actually did under the hood, or what the .NET tooling did under the hood, was actually ran that really long Docker run command there. And what you'll notice is that that's actually using a SAM build image for .NET 8. So what's actually happening under the hood is that a Docker image for what is built on top of Amazon Linux 2023 is downloaded, and then the actual .NET application is compiled inside that running Docker container. What that means is that the code is then compiled on Amazon Linux 2023. After the compilation's complete, the files are then spit back out onto my local file system, which you can see happening. That one there, back onto my local file system. So that's something that you don't need to worry about. You don't need to worry about having Amazon Linux 2023 or anything like that. You just run SAM build, SAM deploy, or .NET Lambda package, and that will all happen under the hood. Obviously, the prerequisite there being that you have Docker or a Docker-like thing installed.
So that's super useful. So but also for people who maybe not using SAM, I think SAM is also awesome for building and deploying serverless applications, specifically ones that have some sort of compilation kind of step. But if people aren't using SAM, or they're thinking, oh, I don't want to introduce another tool, you can use the .NET publish, standard .NET publish command. Obviously, you've got a few more parameters to stick in there, but you can do it yourself.
Yeah, absolutely. The actual CLI command is .NET Lambda package. A package function is the command that you want to actually use, and that will then go off. And I think it's .NET Lambda package function. Let's just check .NET Lambda. Let's not give people the wrong advice, Julian. Just .NET Lambda package. There we are. So you'd run that from within your project directory, .NET Lambda package, and yeah, that will give you that will do that download of the Amazon Linux 2023 image and do all that good stuff. So
when you were talking about Amazon Linux 2023, that is also a new operating system from AWS. It is heavily stripped down in a good way because there's way less in it. And I think there are some on the blog post that did the release announcement. There are some different ways that Amazon Linux 2023 does work compared to Amazon Linux 2. It's also, you may just need to do a bit of research just to check if there's any weird stuff that may happen. But if you basically uses a slim container image to run in Lambda, so there's a whole bunch of extraneous stuff stripped out as well, which also will make the attack surface smaller, hopefully a little bit faster, or at least it will do over time. So yeah, just something to consider if you were using .NET 6 on Amazon Linux 2. This is a slightly different operating system.
Yeah, I've just actually seen a really good question in the chat that I can see. So that's the one. So this is a really, really good point. So you do need to compile the code on the same processor architecture as well as the same OS. So I'm running an M2 Mac, the same as you. And as of right now, Native AOT doesn't support cross compilation. At least I've not found the documentation that tells me how to do it, which means if you're going to run it on ARM, if you're going to deploy to ARM Lambda functions, you need to compile on an ARM machine. If you're going to deploy to x86 Lambda functions, you need to deploy to an x86 machine. So if you're seeing that specific error when you're trying to deploy, if you go and look at your SAM template, why I have the JSON version of this template, I do not know, Julian. But
I was wondering.
So yeah, you just need to make sure that the architecture you specify in your SAM template or your CDK code or whatever it is matches the architecture of your actual machine. So if you're using an M2 Mac, then you'll need to make sure that's set to ARM. And then this can get, if you're using an M2 Mac, but then you're deploying with something like GitHub Actions, which is x86, then this can get a little bit tricky. One of the trade-offs you're making, I suppose, is that you need to have that processor architecture all lined up.
Yeah, but then I think also if you do a SAM build -- use container, it will pull down the build container for the architecture as well. So, because I've had this on Windows as well, where I've deployed and been testing thing on Graviton for ARM64. And yeah, SAM build -- use container will pull down whatever image is specified in your SAM template file. And so in a way, you're not doing cross-platform compilation, but you should be able to do that. And James is going to show me up. Maybe I'm wrong, but let's go for it.
Like
that? Yes, that should be it. This may need to...
Yeah, see what happens. Okay, so it's fetching.
So there we go. Yeah, so that is then pulling the .NET 8 latest x86 64 Docker image. And you can see that image is called the SAM build, called the build image. This is obviously pulled down, but yeah, that should do the trick.
Cool. And that download is absolutely killing my internet connection, so I'm going to pause that. But there we are. That's you've taught me something there, Julian. I'm going to give that a try later tonight because that's something that's always I've always been trying to figure out how to do from my M2 Mac. So there we are. Perfect. So that did actually deploy. I've lost the. Let's just run SAM deploy again, and we can actually see that in action. While that is just deploying, we can come back to that. One of the things I wanted to talk about today, kind of related to this whole conversation around should you have pragmatic Lambda functions, should you have single-purpose Lambda functions, which one do you use when? There's another really awesome .NET library that I wanted to talk about that kind of helps to address that gap, if you will, and that's the Lambda Annotations framework. So if I just edit that project file, you've got where are we? There we are, Amazon Lambda Annotations. So this is a library that we produced, again, to try and simplify the programming model for working with Lambda. So if we have a look at what that actually looks like, if we take a look at this Lambda function here, you see that as opposed to the more traditional way of defining Lambda functions in .NET, where you've got a method that has the API gateway proxy request object, and then you need to manually parse the body or the path parameters or the query parameters. You need to do all that boilerplate code, and then on the way back out, you need to manually construct the response object. The Lambda Annotations framework actually abstracts all of that away. So I've got this same add, subtract, multiply, divide API that actually, as you can see, the code for this actual Lambda function method, this actual Lambda function is really, really simple. You have none of that boilerplate to parse the API request. It's all just built in, and you can get your Lambda functions now really focused on your business logic. This uses that same source generator feature that I talked about for the JSON serialization to actually do the same thing for your Lambda function. So at the point you compile this project, it's going to actually generate all of that boilerplate code. And we can actually, if my IDE is working correctly, which is helpful because sometimes this doesn't work, you can actually go and see all of the actual code that gets generated. So you can see all this code here has been generated on your behalf. So this is the more typical kind of Lambda function definition that you will probably be used to, where you've got a request object, you've got the context, and then you're starting to manually parse out the path parameters, all this stuff that now you don't have to worry about writing. You can just add these attributes to your methods, and this will automatically generate all this code for working with APIs in .NET, which is really quite helpful because it gives you that middle ground. Then you've still got these single purpose handlers, but you're working in a more familiar way of building web applications in .NET with this annotation based programming.
We do have some feedback back from TF Howerton. I think that's, well, thanks for joining us in the cool question before. And switching the architecture to ARM64, then running SAM build worked. Thank you. So some people test in production, some people test on the live stream. So yeah, we appreciate you doing that. Just if you are doing cross compilation and you do need to use SAM build use container, so it'll pull down the correct build container. But I'm glad that worked for you. So excellent.
Likewise. Yeah, awesome. So going back to this Lambda Annotations framework, one of the other things that do, and this explains why I'm using the JSON SAM format, Julian, is that when you actually compile your, let's see this in action. If I delete this file called serverless.template, and then I go and build my actual application, you'll see that, as if by magic, he says nervously, that file should get automatically generated. He says, now wondering why it's not being automatically generated.
One new thing works, something else couldn't. Had to
there
pull
we
apart.
go.
So.
But what will happen is that maybe it's just because the file's not loaded into my IDE. Actually, let's try reloading the project, see if that does it. No. Anyway, so when you compile the application, that will actually generate a SAM compatible YAML file, which has all the handlers mapped up. It has everything needed just to go off and then deploy that using SAM, which is why I'm using this lovely JSON format for managing my SAM templates. The one last thing we released with Lambda Annotations late last year is some support for doing native AOT with Lambda Annotations as well. And then this gets you into this really interesting place where you can still define single purpose handlers, and you can define them all in this same code file. You can have all your API endpoints in the same file, and then you can natively compile them and then deploy them as single purpose Lambda functions if that's what you want to do. And you can do that by adding this additional property to your Lambda function. So you've added the Lambda Annotations framework, you've defined your Lambda functions using these methods and these attributes on all the methods, and then you add this Lambda global properties assembly attribute, and you set this generate main property to true. And what this is, so you'd go through all them other steps that we showed with ASP NET, where you add the output type, you add the publish AOT flag, set that to true. You do all of that as well. But then you also need to add this Lambda global properties. And what this is doing is, because when you use native AOT, all that's being generated is a native binary. It's just giving you a single executable, and that's it. So when that executable runs, it actually needs an entry point. It actually needs a place to go in and start up the Lambda runtime and actually, get things up and running to actually start the application. And you don't have any of that here. You don't have an entry point. All you're doing here is defining methods and Lambda functions. So what this generate main true will do is it'll actually generate all of that boilerplate to the actual entry point of your application. It will do that all again using these source generators. It's actually a really cool feature of .NET that allows you to generate code at compile time. They're quite hard to write. It's all templating, but they're quite cool when they work. So what actually gets generated when you set that generate main to true is this entry point. So for any non.NET developers, a static method called main in a .NET application is what .NET will use as the entry point of the application. And then what we've got is this big switch statement here, which gets quite long from like a code perspective, because you've got to fully qualify every single object that you use. But it generates this statement so that you can then generate one single binary. You can have a single compilation step. You can have a single .NET application. You can deploy that same .NET binary to 4, 5, 10, 20 different Lambda functions. And then all you need to do is set an environment variable to determine which method actually gets called. So when I deploy this to AWS, I'll have 5 separate Lambda functions, all using the same binary behind the scenes, but with an environment variable set to default, add, subtract, multiply, divide. And this allows you to still keep single purpose handlers if that's what you want, but you can define them in a way that is more familiar to building an API as a single project, because in a lot of cases APIs are all related, all the endpoints are related, so you can still have everything grouped together and then compile that natively and deploy them as separate Lambda functions.
So then that's configured as an environment variable rather than changing the actual function configuration for the handler.
Yeah, because the handler will always need to call the actual executable. So you're always going to get that same executable, which in this case will be called Lambda Annotations AOT. So the handler of your Lambda function has to be the name of the binary. And then you're then saying, okay, which environment variable that you want to use. Actually, one of the other really kind of insignificant, but I think really interesting things with .NET 8 is that because you can now, if you were doing native AOT previously to .NET 8, you'd have had to go in and you'd have had to actually set the name of the output binary. You would have had to set the assembly name to be Bootstrap. Because when you're using custom runtimes with Lambda, all that the custom runtime does is look for a file called Bootstrap and executes a file called Bootstrap. So regardless what your .NET application was or what it did, you had to call it Bootstrap. And you don't need to do that anymore. You can get rid of Bootstrap, and you can specify the handler in your Lambda function as the actual name of your actual project, your actual assembly, which I think is just a nice, albeit quite a visual kind of nicety, but it's still nice that you don't have to use the word Bootstrap anymore.
So to explore that, previously the way to run native AOT was to use the custom runtime, or we also like to call it an OS only runtime, so just the bare bones. It was for .NET 6, Amazon Linux 2 runtime, and then you specify the Bootstrap file. Now, when you're using custom AOT, you're actually still using the managed runtime, even though you are running a compiled binary. How do sort of people make sense of that change from before? Why do they need the managed runtime if they are just running this awesome slimmed down and performant managed binary, but not in a custom runtime?
Yeah, it's a really good question, actually. So one of the reasons is the .NET 8 managed runtimes. There's some system libraries, libicu and various other things that are included as part of the managed runtime, which means that you then don't need to bundle them as part of your application code. The other reason being, in custom runtimes, the initialization phase of your Lambda function is build, which is something to think about if you're using custom runtimes. It's one of the caveats I always gave when I was saying, yeah, native AOT is great, but you were built for the init time, so it's something just to be aware of. So there's a couple of really good reasons, as well as the obvious one, which is that the managed runtime will be patched. One of the benefits of Lambda is that we patch the managed runtimes, right? And if you're using a custom runtime, that was slightly more responsibility for you as someone working with the runtime. So there's really good reasons there to use the managed runtime.
And also sometimes even from a manageability perspective, you didn't have, if you specifically if you're running different runtimes or that kind of thing, you had sort of no visibility inside of what your custom runtime was doing. Now it says .NET 8 in the console, and even that as a quality of life improvement. It's like, oh, that's my .NET 8 function, not my 17 different functions all on custom runtime. I don't really know which one's doing what.
Yeah, absolutely. So yeah, annotations is a really good thing to go and have a look at. Let's just see. Oh, of course it failed. Why would it fail to deploy? I've just deployed it twice.
Well, you did do the same build step beforehand, unless that.
Oh, I did with the use container, didn't I? Yeah. Maybe that's it. Let's run that again. And I'll just want to quickly talk about Powertools very quickly. I'm just conscious of the time. So there's been a lot of really awesome work. We've got some really awesome community contributions to Powertools. There's obviously the team internally. So there's Henrique and Amir and Stephen Leidig. There's a whole bunch of really awesome people working on Powertools for .NET. And there's some additional things that have been added reasonably recently outside of the kind of core libraries of logging, metrics, and traces. So Powertools for .NET now supports idempotency. So you can add this idempotent attribute to your methods, your Lambda function handlers. You configure idempotency as part of your initialization of your Lambda function. In this case, this is using DynamoDB as an idempotency store, and this will actually make your Lambda functions idempotent without you doing really anything. You add these 1, 2, 3, 4, 5 lines of code. You can specify. You see here, I'm using some JSON path-like syntax to specify exactly which parts of my input payload are going to be used to determine if a request is idempotent or not. You can now do idempotency with .NET and Powertools. The parameters support is now fully featured, so you can use this parameters manager. There's SSM, there's secrets manager, there's DynamoDB. There's a few different parameters backends that are supported, and you can use that to do secrets management, to pull things. And this manages caching, so I can make this SSM provider.get async call inside my actual function handler, as opposed to like the common best practice of doing it in your constructor, and the caching is all managed inside the provider. And then the last one, really, really rapid fire, I'm sorry, everybody, because I'm speeding up dramatically now, is around batch processing. So there's now support in Powertools to do batch processing that handles things like partial failures, partial completions, and you just specify a handler that inherits from this SQS record handler object. Rapid fire Powertools. There we are.
Yeah, no, Powertools is amazing. And yeah, if you're not using Powertools for AWS, Lambda, Python, Java, .NET, TypeScript, and JavaScript. So yeah, certainly a toolkit for using in your Lambda functions is just going to reduce so much code and make your life easier.
Yeah, and there's a few really awesome YouTube open source creators. There's Rahul Nath, Mukesh Munganathan, .NET Diz. There's a few open source YouTubers, non-AWS employees. What's the word I'm looking for here, Julian?
Contributors,
heroes, not heroes. Anyway, there's other people in the community creating really awesome videos about Powertools and Lambda and stuff like that. So I just wanted to give them a shout out as well, because if you're interested in diving deeper into Powertools, then there's some really awesome video content out there to do that.
Cool. Excellent. I just quickly wanted to, because Chuck did come back and give some more information. Chuck, if you're still with us, appreciate the long wait. But Chuck was previously talking about, well, I'm getting cold starts. My init time is way longer than my actual invoke. What's the kind of point? So cold start took 2 seconds in total. I'm just going to go through quickly. With 1 second for init, and then 0.2 seconds other processes, only 0.8 to process data. Paying 100% tax just to pass data into the system. Why should I bother with Lambda for short-term tasks? Under those kind of seconds may not be the most optimal tasks. Better suited for long-running kind of things. Chuck, in the big picture, you do have a point that you are going to be doing some more stuff in the init kind of phase. But the kind of thing to think about is the busier your application is, the actual fewer cold starts you're going to have. Because when you're testing it, you're going to invoke one Lambda function, cold start. Invoke one Lambda function, update the code, cold start. And it's going to look terrible. But as soon as you scale up your application, that cold start's only going to happen on the very first time an invocation happens. Subsequent invocations are going to use then that pre-warmed Lambda execution environment. Now, if you're not aware of how the Lambda execution environment works, there's some good YouTube videos and documentation on that. But basically, there's a lot of reuse that happens in Lambda. And so, yes, the first time you're going to get a cold start, but subsequent requests are just going to be super fast. So what I'm sort of saying is, don't sort of throw the baby out with the bathwater and think you're going to be doing a whole bunch of stuff unnecessarily. Also, James did hint at that. Also, when the init phase is a different pricing model, so it isn't as expensive. Different charging from the actual invocation phase. So it may not be a big problem as you kind of think. So definitely, as you run it at scale, hopefully it's going to be less of a problem.
It's the interesting, the kind of curious case of AWS Lambda that the more scale you give it, the better it gets. It's kind of interesting.
No, it's counterintuitive, but I've been talking to some people, and they run production applications, and it's sort of 0.5%, maybe 0.7% of all the invokes are cold starts. So quickly said before we say goodbye to James, next week we've got Kafka and EventBridge, a whole different world. Dave and Michael are going to be talking about how you can combine these two in various ways for doing your data stream processing. What else did I have? I have something over here. Don't forget EDA Day in London, May the 14th. Would be great to see you. And also serverlessland.com, lots of code, snippets and everything all about serverless on AWS, including patterns. So if you are building with .NET and you want some infrastructure as code patterns, whether using SAM, Pulumi, Terraform, CDK, all these kind of things, plenty of code infrastructure as code patterns you can grab, which may be useful in your applications. James, thanks for the awesome tour through .NET 8 and showing us all the cool things. It's going to be faster. It's going to give you more functionality. Seems really simple to upgrade, so why not?
Why not, indeed? Absolutely.
Excellent. Well, James, thanks so much, and happy building .NET applications, everybody. See you same time, same place.